From the loan you apply for to maybe even a medical diagnosis you get, AI is making huge decisions that shape our lives. But what happens when we ask why it made a certain choice? How do we make sure that its reasoning is fair, that it's transparent, and that it's truly understandable to everyone? This quote from the research really just nails it, doesn't it? This isn't just a tech issue, it's a fundamental right. We need to be able to question these systems to understand their logic, especially when the stakes are so incredibly high. And that's where this whole field of explainable AI, or XAI, comes into play. The goal is pretty simple, actually. Make a black box AI more transparent. Basically, it's all about getting the AI to show its work. Just like you had to in math class, so we can see exactly how it got to its conclusion. And this is a big but. There's a huge catch. What if the explanation is presented in a way you literally can't see? This is where researchers found a major accessibility gap, one that really challenges the whole idea of what it means for AI to be explainable in the first place. So to figure out just how big this problem is, researchers did a really deep dive. They gathered up and analyzed 79 recent important studies on explainable AI to see how we're actually testing these so-called explanations out in the real world. And as they were sifting through all this research, they were really looking for an answer to one single crucial question. When we're testing if an AI explanation is any good, who are we actually testing it on? Are we including users with disabilities in the conversation? And the answer they found is, well, it's staggering. Out of those 79 studies, a full 96% made zero mention of accessibility at all. Just 3 papers, that's a tiny 4%, even touched on the topic, and that was mostly just about colorblindness. It's a massive systemic blind spot in the entire field. So why is this gap so enormous? Well, it's because the most popular tools we have for explaining AI are almost entirely visual. Methods like Lime and SHAP, they usually spit out bar charts. Another one, GradCam, creates a literal heat map over an image to show you what the AI was looking at. They're all designed to be seen, which creates this huge barrier right from the get-go. Now, faced with this pretty bleak reality, the researchers didn't just stop at pointing out the problem. They went to the next logical step. They decided to try and solve it. They set out to design and test a system built from the ground up specifically with non-visual users in mind. To make sure their work was grounded in reality, the researchers created a really specific user persona. So let's meet Caroline. She's a 45-year-old professional traffic manager who's been totally blind since birth. Her job depends on making sense of AI-driven data, but all the explanations she gets are charts and graphs. Caroline is the exact person that current XAI systems are failing. They followed this really smart, methodical approach. First, they picked a realistic scenario. Then, they filtered it through the lens of Caroline's needs. That thinking guided the design of a working prototype, which led to the most important step of all, putting that prototype into the hands of actual users, with sight loss, to see if it really worked. Okay, so here's how the experiment actually worked. They built a prototype AI for Caroline's job, one that predicts urban traffic. The goal was for her to understand why the AI made a certain prediction. To do this, the system gave her explanations using those common techniques, Lime and SHAP, but it offered them in 2 different flavors, a really detailed version and a much simpler summary. So they put the prototype in front of real users. What actually happened when people who rely on screen readers started interacting with these different AI explanations? Well, the results were both surprising and incredibly insightful. Here was the absolute core finding. Every single participant agreed that the simplified explanations were way easier to understand. Yeah, the detailed versions had more raw data, but users often describe them as just overwhelming. The simplified explanations, on the other hand, gave a clear, direct overview that was just plain better for getting the big picture. And this quote from a participant explains the problem perfectly. They said that even though the information in a table was readable, a screen reader can read every single cell, its actual significance was often unclear. Just because data is readable doesn't mean it's understandable. So what's the bottom line? What works best? Well, the feedback was crystal clear. People preferred simple text, either in paragraphs or bullet points. Those really complex tables, a major challenge.
And it all points to one fundamental conclusion. A one-size-fits-all, visual-first model for explanations, it just doesn't work for everybody.
So where does that leave us? What does all this mean for the future of AI? Well, these findings are really pointing to a necessary evolution, a big shift in our goal from making AI that's just explainable to making AI that is truly accessible.
If there is one thing you take away from this, let it be this. A one-size-fits-all explanation is doomed to fail. True explainability isn't just dumping a bunch of data. It's more like a conversation, and any good conversation means tailoring what you say to the person you're talking to, thinking about their background, their needs, and their abilities.
The great thing is, this research gives us a clear blueprint for building that future. It all starts with involving the disability community in the design process right from day one. It means offering explanations in multiple formats, text, maybe sound, and whatever else works. It means following the rules that already exist, like the Web Content Accessibility Guidelines. And ultimately, it means completely redefining our goal.
And that leaves us with one final big question that gets right to the heart of this whole thing. As we build these incredibly powerful AI systems, we just have to ask ourselves, is an explanation really an explanation if not everyone can access it?